You are a senior staff research scientist on LLMs at Meta's AI organization. You've been integral to the training of the Llama models, arguably one of the most widely used and best open source LLMs today. Maybe to set the stage and start off our chat, how has it been like being at the center of such an important moment in AI today?
Right. Look, it's weird. Maybe a quick anecdote I can tell you is I'm based in Paris, where it's very AI high, but less than in San Francisco. And when I went with my wife in San Francisco like a few months ago, she was like, we met people in the street or like in a restaurant, oh, you're the guy from Llama. And she realized it's something.
Yeah.
And like here,
Yeah.
all my friends are, oh, you're working on AI, cool. Like, do you do data science?
Yeah. And yeah, in San Francisco, people were stopping you on the street. So yeah, I think I recently saw a video of some Altman with paparazzis behind him. It's a pretty interesting moment in AI today. So you just unveiled Llama 405B, which is an incredible milestone in open source AI. Maybe walk us through Llama 405B in a bit more depth, which I think is the biggest open source LLM out there. What makes it unique to other open source LLMs?
Well, the size, of course, but beyond that, and that just one scaling dimension, is the scale. We train it on, again, like 15 trillion tokens. With respect to the preview release we did at the time, we have done much more post-training, LLHF, so the alignment is also much better. And so the resulting performance follows. Let's see the results on the Arena leaderboard, for instance, and other benchmarks. But I'm hopeful that it will be the best performing model out for open source. It has long context. It has, although we may not release it like multimodal and other like capabilities. So it's really filling the gap with the frontier models.
And, we're definitely going to talk about deep dive into the training of Llama 405B and also all of these models. But maybe when when we're speaking about training of these models, right, this is quite a technical challenge when thinking about the scale of Llama 405B. Maybe before we talk about Llama 405B, just general training these large language models, what are some of the biggest challenges in developing these models and how do you navigate these challenges?
The biggest challenge to me is how to balance exploration and exploitation. And let me elaborate. Like, when you do some experiments, you cannot do that at the 405B on 15 trillion tokens and do like 20 ablations. That's just not possible. That's the kind of run, even for smaller size, to be honest, like 70, that you put a lot of resources of this one. And so you need to be confident with the hyperparameters, with the data, the training mix, everything. And so how to choose that, you need to do smaller scale experiments. And to then infer the right parameters at a larger scale, you need to infer the right data mix. Maybe like a simple example. What is the impact of multiple epoch? So repeating the same data multiple times at a larger scale. There's more weight, so the model memorizes more. And so you could have some new phenomenon that you didn't observe at a smaller scale. And how to trade off this unoptimal large-scale run, because we just couldn't grid search everything, versus the exploration you want to do at a smaller scale is something tricky. And so how even to balance the resources between exploration and exploitation is very challenging.
Okay, and maybe walk us through some of the best practices that you guys have developed while having that balancing act between exploitation and exploration. What would be your advice for, the small handful of other teams looking to train large language models?
I think in general, the best advice is to follow first principle. Like, okay, garbage in, garbage out, for instance, for the data. And data is probably one of the most important thing. So making sure that the data you collect is high quality, reviewing it manually with some processes, with quality analysis, some classifiers. We use Llama to do that and select the tokens for pre-training. And making sure like you validate your ideas and your intuition with a run at a smaller scale, and you see the improvement. It's never guaranteed, but it's likely to lead to some gains at a larger scale. And I would say at every stage of the pipeline, being very, very rigorous and meticulous to get the best effort, to have the best class pipeline.
Okay, that's great. And you mentioned here the data and making sure that the data is high quality and doing qualitative analysis. I'd love to learn a bit more about that because, massive amount of data is going into training these models. How do you make sure that this data is set up in a way that you're able to ingest it into these models and have confidence in the output? So I'd love to see kind of what are the processes that you adopt to make sure that the data is high quality, because that's a big aspect of making sure that the model is successful in the long run.
For pre-training in particular, I don't know if you want me later to deep dive more in post-training and LHF, but for pre-training, you just collect basically web tokens. Let's say you have like famous data sets like Common Pro or the Pi. But the truth is that the web is garbage. It's just random. If you look at a random paragraph or document from this data set, it's random noise. And clearly there's something wrong to train your model on 50% random noise. Like it's a waste of compute. So the first basic thing to do is, can you train a classifier or using some heuristic or machine learning models to select what is the right token? Then can you do some topic classification? Maybe you can rebalance your data mixture such that it covers not like 0.5% some domains, but it's more like balance. You don't have like a hole in your racket in the knowledge. Then can you add additional sources? What is your pipeline to clean the data? Like if you convert, for instance, we developed Nuga last year that performs a scientific OCR. Just putting a lot of effort in this model so that you end with a high quality text from a PDF and scientific text leads to improvement on reasoning, for instance.